Yeah, let's see, I got 8 o'clock. Are you guys ready to start? Oops. Where'd Malika go? You're on mute, Casey.
She's still here. At least we still see her screen. That's a good sign.
Yeah, that's a good sign. Get a cup of coffee or something. Unless you want to start out,
I don't think we want to deviate from her plan.
Okay. You ready to go? You're on mute, by the way, Malika. But you ready to go? Should I let people in?
Yes. Ready.
Ready? Okay.
All right, everybody, welcome to Mosquito Habitat Mapper and Surface Temperature Workshop. I hope you are excited as much as me and Casey. Really, we really thrilled, okay? And I would like to share my screen. Okay, so we will actually know that you guys actually attending at the right workshop, not the wrong one. If you still have time to change your mind. Okay, my name is Malika, and Casey, would you mind to say something and introducing yourself?
Hi, nice to see everybody today. I'm Cassie Sofing. I'm with the Institute for Global Environmental Strategies and part of the NESIC collaborative, and IGES is a Globe partner.
Okay, I think Casey and I will entertain you guys tonight. I mean, in Thailand, it's 9 p.m. Okay, so it's a nighttime for me. We are so happy to have so many people joining us today. Okay, I don't want to waste any more time because we only have 1 hour for me and Casey to entertain you guys with the workshop. Okay. For the workshop, we plan together that the first 20 minutes, we're going to go to why should we do Mosquito Habitat Mapper app. And if you're not familiar with this, you probably wonder what is the Mosquito Habitat Mapper app really is, right? Um, we having more people joining in, okay? How can we use Mosquito Habitat Mapper app? How to collect mosquito data? And then we will talk a little bit about Globe Zika Education and Prevention Project, okay? And then Casey will take you to the Globe Mission Mosquito. Really all exciting, taking observation and resource, how to take a good photo, because good photo means a lot to us, right? Uh, Otherwise, we could not identify mosquito, counting number of mosquito in each breeding sites. Okay, the data will be more meaningful if you have a good photo of breeding sites that can see mosquito larvae in it. And then hopefully the third trainer would join us. I hope I'm not sure. I never met her. She would talk about Globe Observer website, and if she's not, Casey will actually lead you to the Globe Observer website. Okay, you will enjoy how to get the data and how to visualize your data along with other Globe protocols data that also available besides mosquitoes. Okay. And then hopefully we will have chance to talk a little bit on how other global protocols, for example, like air temperature, relative humidity, or water pH or soil moisture actually do have some influence on mosquito larvae, okay, in your area. And then hopefully we will have 10 minutes left to answer some of your questions, okay? Okay, this is what we plan to do for 1 hour. It's really packed. It's going really fast. It's gonna be fun. Okay. If it's not fun, you guys can just keep it to yourself. Okay. You're not going to. But before this, I would like to share with you 1 minute video on YouTube. I know that the voice is kind of low, but they have text layover. I got it from YouTube. I thought it's inspiring. Okay. So I hope that you inspiring. Oh, sorry. I need to stop. So I hope that you're inspiring about mosquito. Mosquito do have different type or different species, and each species they have specific diseases. Okay, for example, the one that it's affect many people in many areas is Aedes. Okay, Aedes species carrying Zika, Dengue, chikungunya, and filariasis. Okay, and if you have anopheles in your area, you definitely will have malaria. Okay, at the moment, malaria you will actually have some drugs that can help you get better from having malaria. But for dengue cases, it's kind of harder. Okay, and for you have Culex, Amicidis, and Mansonia, different type of mosquito actually carrying different type of disease. Okay. This is a global distribution of dengue, Zika, and chikungunya. As you can see, there's a big belt over here, okay? And different color mean different type of, the blue one is Zika and the yellow one is dengue, okay? Blah, blah, blah. And then I want to point out in the US, because I saw that some US participants attending or applying for this workshop. For the US area, for the Aedes aegypti is the distribution look like this. And for Aedes albopictus, this is also Aedes. But the major vector that carrying dengue and Zika virus, the main vector is Aedes aegypti. Is in 2A, okay? And for the second main vector would be Aedes albopictus, okay? And this is the area that they're spreading in the US. And as you can see, is keep spreading to north and west of the country, okay? And when you're talking about, when you want to know how many people, how many countries actually affected by dengue, this is the world map of dengue cases in 2020. Okay, as you can see, so many countries has been reported dengue cases, and the highest number is the largest red circle here. I think is Brazil. Okay, and the Brazil last year reported more than 1 million people that have dengue. Okay, so the most dengue cases in 2020 is Brazil, Paraguay, Mexico, Vietnam, and Malaysia. Okay, and I want to show you that mosquito, when you want to classify them, mainly there are three different subfamily, which is Anopheles, Anophelini. This one is carrying for malaria and Culicidi. Okay, this one has Aedes, Culex, and blah blah blah, and this one carrying dengue, Zika, chikungunya, and filariasis. Okay, and this is toxorhynchitis group. Toxorhynchitis group, we call giant mosquito. They do eat other mosquito larvae as food. Okay, so many people thinking about using this as a biocontrol. Mhm. Some people wonder, would we only have few species of mosquito? I want to point out that mosquito, for example, like in Thailand, we have 416 species. And in the Philippines and Malaysia and Indonesia, as you can see in Southeast Asian country, you have between 300 to 500 plus species of mosquito in the area, but not all mosquito species carrying disease. This is the what the adult mosquito look like. Okay, they do look differently between species. And for mosquito larvae, the way that they stay on top, they're hanging like Anopheles. This is carrying malaria. This thing they actually parallel to the water surface. But for Aedes, they have 45-degree angle for the water surface. For the Culex one, the Culex tend to live in a very dirty water. Okay, so they usually have really long siphon. Okay, so different mosquito larvae, they do look differently, and they actually park themselves, thinking them as a car. So they actually park themselves near the water surface differently. It depends on the siphon. For Anopheles, they really have a tiny, very short siphon. So they really hanging have to be very close to the water surface, and you generally tend to be clean water. Okay. For toxorhynchitis, this one usually 3 times bigger than normal mosquito larvae, and they eat other mosquito larvae for food. Okay. If you guys are teacher, okay, or if you guys are trainers in your country, one of the fun activities that you want your students or group student to do is ask them to draw mosquito life cycle. Okay, It's kind of nice, it's kind of fun, and it's kind of interesting to see some of them might draw something that look like butterflies or something like that. So I want to share with you on for the video. So after you ask them to draw mosquito life cycle, and then you show them some video on the mosquito like this, I think they would be surprised that mosquito have hair, okay, that's sticking out, and they also have some pupa staying on top, okay. So this is you can start filming this thing yourself with your cell phone and use it as a classroom material. It's a nice way to draw your student attention after they start drawing mosquito life cycle activities, okay. The second on the right hand side is mosquito life cycle that actually showing how many days, let's say that from eggs, okay, it will take them 1 day to hatch, and then from tiny larvae have 4 different instar, okay. Once they turn to be the 4th instar, they're going to change to become pupa, and then from pupa it will take them 2 days to become uh, they actually emerge from water, and then they become mosquito, female mosquito that very hungry, and they're ready to go and suck your blood, okay, and take your blood meal. And after that, after they actually get your free blood meal already, it will take them 2 days to start, 3 more days to start laying eggs, okay. So the whole cycle of how many days that they would survive in nature, probably less than 10 days, okay. And imagine you can bring these bring the story about climate change, how if you can ask them or set a scenario that if the water temperature increased by 2 degrees, what would your student think, what would happen to this mosquito, okay. As you can see, their life cycle will be faster, okay. They will go through larvae, it could be shortening by 2 days. Let's say the larvae shortening by 2 days, that means they become a pupa. What would happen? They will be a tiny pupa because they spend only few days, 2 days to find food to and then they start to changing changing their development stage to pupa, and once they hatch from the pupa to become a full-grown adult that flying around and try to suck your blood, that means they will be a tiny female, okay. And for the tiny female, they hungry more frequently. They feed the blood meal even at higher rate because of the hot air. And then they finish their life cycle early. They hatch early. They lay more eggs. They lay eggs faster. So the cycle of transmitting disease will be faster if the water temperature increased by 1 or 2 degrees. Okay, this kind of thing you can bring it to your student in the classroom. It will be fun. It will be fun to ask them to think and then challenge them during the class and add the climate change effect on this. Okay, Globe providing some information, and this is the information that you can download from the teacher guide on the Globe website. Okay, this is what I usually give it to Thai teacher when I conducted some workshop. So I providing them with mosquito larval identification key that match with the mosquito that present in Thailand. Okay, so I group and I pointed out that what they should what the teacher should be pay attention to, like pitchfork, and then on the comb scale, okay, and then this is really long siphon for Culex, okay, blah blah blah. um, so you could do that with your teacher. I only have 1 minute left, but I'm gonna go quickly on the mosquito habitat mapper app. Okay, this you can download it from App Store. Okay, and from the app you can use the app to identify mosquito larvae, and then after you take a photo of the container, or they call breeding sites. Then you can eliminate breeding sites, and once you dump the water out, take the container and put in a trash bag, and then whatever your action is, that would prevent future outbreak. Okay, and this is when you start as a citizen science. Some people might join these as citizen science. You have to create a new account first. Okay, by doing finish all these, and then this is the Mosquito Habitat Mapper app. This is what it would look like on the Globe Observer app on your cell phone. As you can see, you can do cloud, you can do land cover, you can do tree height, but you choose Mosquito Habitat Mapper app. You click it right here, and then you go through all these. You can see that the app providing latitude and longitude and location of where you take observation for the breeding sites. Okay, and then you go to identify breeding habitats, right? You have to choose one of these. For example, you choose a water storage container, and then it will pop up some of these like these, and then you will click which one. This is a cement tank, this is a jar, or this is a fountain or bird, blah blah blah, and then you take photo. Okay, from the photo you take the photo, and then you click upload your photo. You can upload up to 9 photos. Okay, and then in a few minutes, Casey will go through how to take a good photo. This is very important because we want to see mosquito larvae, so we can estimate how many that present in the breeding sites. Okay, and then if you have a chance, you can identify up to species level, and the main thing is you have to dump the water out. Okay, so once you dump the water out, uh, you will mitigate it, right? And after you finish all these, after you dump the water out of the container, and then you submit your observation, you will get frog egg. And if you keep doing it, your frog egg will hatch, become a frog, and then become a tadpole. And then after the tadpole, at the end, after you do it so many times that you help the GLOBE program identifying and dumping and cleaning mosquito breeding sites, you will get a frog at the end. Okay, it's a game. Uh, this is if you see the successful and you click OK, this means you successfully send the data to the Globe website. Um, Casey will show you about Globe visualization system. Okay, it's even though you are not a member, but you still can use the Globe visualization system. Is under hydrosphere. You choose mosquito habitat mapper, and then you do data count, and you select the date right here. Okay, this is what I captured today. This is so many data points from Globe Mosquito Habitat Mapper app. As you can see, there are so many data points actually submitted to the Globe website nowadays. And you also doing visualization with other globe measurement. For example, you can choose to do with water pH, okay? And also there are other additional materials that, and I would like to introduce maybe 30 seconds on Globe Zika Education and Prevention Project, okay? You can go to the link on the Globe website right here. It will lead to the project on the Globe website. On the Globe website is 3 main region. It will be 3 main region. The first one is Africa and Asia Pacific and Latin America and the Caribbean. These 3 regions with these countries joining the Globe Zika Education and Prevention projects, and there are quite a few data, maybe more than 50,000 data points being submitted through this project. Okay, It's a wonderful, great project. And in that particular set of Globe website is also showing mosquito protocol bundles, how you and your students can, besides doing Globe mosquito habitat mapper, they suggested for atmosphere, you could do air temperature, precipitation, relative humidity, along with mosquito larvae that you collected. And also you could do hydrosphere. Like you can set some question on water temperature or water pH. We could do pedosphere on soil temperature and soil moisture. Okay. I think this is pretty much I would like to share with you for now, and I would like to I would like Casey to start on. Let me move my PowerPoint. So Casey going to show you on Globe mission mosquito. Okay.
Good morning, everybody. How are you? I'm just going to ask you if you can raise your hand. How many of you have updated your Globe Observer app to the current version? For example, did you know that there was a major update to the mosquitoes that was launched yesterday? Ooh, that's awesome. I see a couple of hands going. If you haven't done it already, take a moment, maybe while I'm talking, to get that app updated. I think you'll be really happy with some of the changes that were made. But I'm with the Globe Mission Mosquito campaign, and I wanted to just share with you some of the features of our campaign website. And if you haven't had a chance to visit us, I'd like you to jump right out and kind of see what it looks like. So from the homepage for Globe, you can find us. Here's my short trail right here. In my URL is right here. Within our webpage, we have topics, home protocol, how to participate, webinars, which we do monthly, some videos, links to student research using mosquito habitat mapper data, a resource page, hot news on mosquitoes, and a blog, and then to meet the team. So I'd like to just start with just kind of a review of what is on the homepage here. So does NASA study mosquitoes? We have a link to a video. Well, yes, NASA studies the characteristics surrounding mosquitoes, but not the mosquito necessarily itself. Over here on the side, as Mulika mentioned, mosquito larvae hang at different positions in the water. So we have some imagery just to kind of remind you of what genus does that. We also have down below this, that doesn't quite show, there's a link to a video. And the videos are pretty short, and I just wanted to kind of share one of them with you.
Okay, now that we've seen the flow chart, I think you have sort of a broad overview of what we're going to do. And here is our specimen. It's moving very slowly, so we're going to be able to look at all the features and determine what we have here. So here is our euthanized specimen. It is now moving very slowly. And now let's take a look at all these different.
So those of you who have had a chance to look at mosquito larvae using a clip-on magnifier, you know the struggle that we're dealing with these larvae. They're pretty active when you first put them on a slide to take a picture of. And so one of the ideas that you can use is a drop of hand sanitizer will slow their activity down. But information here on our homepage. The next slide again references the mosquito bundle that Mulika talked about, the protocols that would help you to understand the climatic relationship mosquitoes have are air temperature, precipitation, and relative humidity. All the protocols in the hydrosphere, in the pedosphere, soil moisture and soil temperature, and in the biosphere, the land cover and the green up and green down. And those are there because mosquito habitats are where you find the water. mosquitoes are very sensitive to those changes. If during my, if you have any questions at all, please be sure to put them in the chat, and Melissa and I will take our best shot at answering them. On this webpage also, there is a video link at the bottom below this one. And I know that if you're teaching or sharing about mosquitoes, sometimes you're looking for the best references that you possibly can. This video is just an excellent example. I'm just going to squeeze forward here about looking at a mosquito larvae, because we're looking for some diagnostic characteristics. We're looking for a specific head, thorax, and abdomen section with the tail. And so here's a raft of mosquito eggs. So you have an idea of what those look like if you see them on the surface of your water trap or your larva trap. And as they hatch, they're pretty active wigglers. And with the culex, you see the very long siphons that Melissa mentioned. But this is an excellent video that is available. You can download it from our website, but also on YouTube. And just kind of giving you an idea about what you'd be looking for. But they're fascinating, and something specifically you could put a jar in your presentation classroom or with your students to kind of pick their interest then. On the Globe Mission Mosquito webpage, we also have a series of very short training videos. If you're wondering how to put a clip-on magnifier on your smartphone, what are you looking for? How do you do it? How to sample water. It's not just putting a scoop in the water and going deep. You're looking to skim the top of the water where the larvae would be. Then the video talks about how to do all of that. As Melissa mentioned, how to launch the Mosquito Habitat Mapper tool. We have a couple of keys, but how do you key out a mosquito? Things to look for to find out what the genus. It's a paper activity that you could also do from within the app. I found in my trainings that it's kind of tricky. Sometimes we have people making the observations, but sending in the observations, they kind of forget that last step, and they hang on to them in their phone. And when they end up with too many observations, sometimes sending them up to the Globe Observer site kind of hangs up around there sometimes. So as soon as you make an observation, having people upload them without bulk uploading them would be easier. And then a short kind of a description of mosquitoes in the United States, and all done by Dr. Rusty Lowe. Under the resource section, the Globe Mission Mosquito team has been working on gathering some classroom activities for to use, and we have a specific page. We have two brand new resources, the Mosquito Larval Hunter Training Level 1 and Level 2. And it's designed for middle school kids, but I think you could either kind of grade appropriate it down to 5th, 6th grade, or up a little bit to maybe freshmen and sophomores in high school. But you're reading through a list, you're learning how to spot a mosquito larvae versus an imposter, because there's an awful lot of wiggly things in water samples that you think could be larvae that turn out not to be. And so there's some activities that walk you through that. We have an activity that says, what happens when a mosquito bites you? What to look for? How do it's kind of an infographic. And probably one of the more fun things to do is to play habitats and hideouts. But it takes a look at all the icons used in the Globe Observer tool, and you learn to match them up in kind of a bingo game format. This activity that I'm kind of pointing to here is kind of creating your own phenology map, taking a look at the temperature and climatic conditions early in your year, and do you happen to see mosquito larvae? Did a mosquito bite you? That's a sure sign there's going to be some females with eggs somewhere around where you are. but there's a whole bunch of resources that you can take a look at. Which leads me to my kind of my next pitch is that the Mosquito Habitat Photo Challenge is starting July 25th and goes through August 25th. And scientists need your help. They're looking for photographs specifically of mosquito larvae. And we need literally thousands of larvae images. And I'll talk about the way to take those photos in a moment. But we also are looking at the land cover because mosquitoes don't just happen, they are laying eggs in water environments, and that's a land cover type. And so there's 4 science teams that are looking to create an AI, or an artificial intelligence algorithm for mosquito habitats. And there's one team looking at mosquito larvae. And we have on the Globe Observer page an entire photo challenge, how to participate, how to get started, a whole bunch of resources that are available to you to download, to use in trainings to spread the word. So I encourage you to check that out. This is the most recent Mosquito Larva Hunter Level 2 training. And it's actually taking screenshots of the app and talking about magnification of samples. So looking at a whole mosquito larvae and then tuning in to look at specific features and going through and just you're learning how to use the key at the same time. And then we have, so there's 2 mystery larvae specimen number 1 and mystery larvae specimen number 2. And through the activity guide, then you'll have an answer sheet. But if you're doing a presentation or whatever, we also included 2 blank documents so that you could have participants fill those in as you go. Now the photo challenge needs really good mosquito larvae photos. So we have it's called the 1-pager. So we're helping to improve mosquito disease prediction maps with your photos of the habitats and the larvae. And it's a critical piece in a complex environmental story. So we have some tips on getting started, what it would look like, and then what you would need to do, and then why does it matter, so that you have some reason for why you're taking land cover photographs with your mosquito larvae photos. On the back, how to use a clip-on magnifier. And it doesn't matter if you're using a clip-on version that looks like mine, that's easy to get off the interweb. They're between $3 and $7. That's the prices that we've been finding. Or whether your clip-on looks like this. They both do the same thing. You're both making sure that you turn on the light source that goes with it, whether it's the smaller one where you twist the cap or the larger one where you press the button, but you're going to turn on the light source. And then after you line it up on your phone, you're looking for a perfect circle in the center. And my mouse is pointing at the image here, but you're looking for that circle. Get that centered on your phone. And then don't be afraid. Both of the tools, both of the clip-on magnifiers have a protective shield around the lens itself, but put it right down onto your specimen. Your specimen will probably be in a drop of water on a white paper plate, because white is a very good background for taking your photograph, but put that down straight on it. And then use your double tap on your smart device to center in the focus. And we're looking for 6 images at a minimum. You can take up to 9, as Molika mentioned. We're looking for 2 full body, and we'd like to make sure that you can separate out all the little hairs. If you have a drop of water around your larvae, that should get those hairs to kind of float away from the body. If you don't have any water and it's a great specimen, put a drop of hand sanitizer on it, but some liquid that's clear that would kind of get those hairs to float up. And then take 2 photographs of the tail section, because we're looking again for the hairs, we're looking at the siphon, and we're looking at the other features in that anal segment. And then back up to the head, making sure you get, again, all the hairs but the head and the thorax. And we have some images there for to use as a guide. Any questions at all? I'll quick peek on the chat. If you do, be sure to let me know. Now, along with the challenge, it's kind of good to see where you've been taking observations. And for the challenge, we have a geospatial dashboard that we've created. And I have the link at the top. You're welcome to go out and check and see what it is. And I'm happy to do a live demonstration of it also. But I just zoomed into North America, and all of the dots showing in my dashboard right now, there's 939 observations, 391 mosquito larvae photographs. And then the one thing we have a lot of are where you're taking the mosquito larvae sampling from. So a lot of water source images. And in there, we also have 2,500 land cover observations. Below the dashboard here, you can see that there's a graph, and this data is only showing starting January 21st of 2021 through last night. The data gets uploaded once a day as your mosquito and land cover photos go through photo approval, then they're uploaded to the database. And so if I were to take, for example, one image, and this one right here, I clicked on it, you'll be able to see your larva or their larvae photographs if they have any, or water source. But there's 52 observations from this one point that you can see. So they've taken a lot of larva photographs, water source, and that's all that's showing on this one. I'd like to show you the kind of the live demo. I think I'll go out on a limb and give that a try. Let me share my screen again. This is what the dashboard looks like. And as you move it around, take a look over here on the left, but you'll see the values are changing. And as you zoom in, again, you'll also see that the values are changing. If I just want to take a look at land cover, I can click here and I can hide the mosquito photographs. And then I can again zoom in. And if I click on a dot, I'll be able to see the photographs in the north, east, south. But within this dashboard, you can see all of the data that was collected. You can also see the date, the latitude. They took a total of 6 photographs, but you'll see all the information right here. Now, this is different from the Globe Visualization Studio. You get much more information from that. And so if you're looking to do student projects, if you're looking to get more in-depth analysis, you certainly would make that choice for there. This particular dashboard is just meant so that if you're doing some trainings and you'd like to see what's in your region in kind of near real time, it's just a quick and easy tool for you to use. And with that, I have links to the observer.globe.gov mission or mosquito challenge. If you're looking for our resources, you'll find that on globe.gov/web/mission mosquito overview. And if you'd like to take a look at the Mission Mosquito Science Notebook, you'll find that with this link. And then my name if you need to contact me. But that's what I have. Thank you very much. So
That's
back to you,
very
Molly.
nice. Yeah. Casey, that's very nice. I've been answering some question in the chat. So maybe before we have 15 minutes left, anybody would like to ask Casey about her some of the things that she presented, so she can directly answer you the question. Uh, you could type in the chat box and Casey can address the question. While you're still thinking about question, I'm sure that Casey can type and answer it. And I don't want to waste your guys' time. I want to show you some of the results that we have done in Thailand. Maybe it will be inspiring for other countries as well. Okay, but this talk will be on my lightning talk tomorrow. Maybe late night for you guys tonight, but for Thailand time, it will be 6:40 tomorrow morning Thailand time. But right now, I am at 9:45 p.m. Okay, so I would like to share you on the thing that I'm going to present on lightning talk a little bit. Okay, while you asking, you can type in your question. Chris and I are working on how we going to prove that mosquito habitat mapper really do make some impacts on dengue outbreak. Okay, I'm going to show you that we conducted the work at 4 sub-districts in one of the island in southern part of Thailand. Okay, we collected mosquito species, breeding sites, container type, lit without lit, indoor, outdoor. Okay, this is Thailand, and this is the location of an island right here. Okay, and so when I zoom in the island, there are 4 sub-districts like this. Okay, Mae Nam, Bo Phut, Lipa Noi, Ang Thong. This is the sub-district. This is the location on the sub-district. And then we have 10 people per sub-district. Abraham, do you have some question? Do you want me to stop and answering your question first? You have some question, Abraham? If not, why don't I finish my presentation, and then we will give you guys time to asking question. Okay. Here I have 10 staff per sub district, and each month they going to go and collect 120 houses per sub district using Globe Mosquito Habitat Mapper app, and we conduct these for 3 months already. And here is the container. They have a type of plastic container for the water storage. They also trash. Okay, you can see they have some broken bucket. They have some plastic cup. They have used tile laying around their houses. They also have some decor, some house decor. Okay, like small pond, water lily thing. All these can actually have mosquito larvae as a breeding sites. And what would happen? This is the data that been uploaded on the Globe website. I use a Globe visualization system. As you can see, within 3 months, there are so many data being collected. Okay, and this is how the purple triangle is how many mosquito breeding site being dumped, get rid of. Okay, and now you want to see what would happen. Okay, this is the first sub district. The first month is 40% of the houses that have positive mosquito larvae at that house from 120 houses. And then the number of houses that found mosquito, we actually went back and collecting at exact the same house, and it turned out to be that number of houses that found mosquito declined from 14 to 18. And this is number of container that in that particular sub district, it decreased from 15% to 11%. Okay, And then you can see this is a second sub-district changing from 23% of the house that found mosquito larvae to 8%, okay? From 32% container to 8% of positive container. And this is the third sub-district, okay? This is 40% of the houses decreased to 17. This is 16% of a container. From, let's say, 100 container, we found 16 that found mosquito larvae in that water container. And by the third month, it's only 12%. And then this is the last sub-district. First, we found that the first month, let's say we have 100 house, 80 houses found mosquito larvae at that house. 80 out of 100, so that's a lot, okay? And by the third month, after we've been talking to the house owner and being collected and dumping and cleaning mosquito breeding sites, is down to 2%. That means only 2 houses that found mosquito larvae from that 100 house. That's a huge impact on the community. And this thing is a container index. All 110 container, we found all 110 container that have larvae, okay? All container have larvae in it. And then by the third month, only 2 out of 110 container that had mosquito larvae, okay? As you can see, that different sub-district people react, or community react to, or how they would engage and want to clean and help their community get rid of mosquito, which is main vector for the dengue outbreak. Okay, we were so amazed that first we found there are some variation in human behavior, but all 4 sub-districts, the mosquito larvae changing from 40% to 16%, and the maximum is from 80% down to 2% of the house that found mosquito larvae, and the containers that they found in each, the percentage of container that found mosquito larvae in it also decreased, but the amount of the level of the decrease depends and it varies between sub-districts. But I think, in short, Mosquito Habitat Mapper app, if the local community adapt using this app, is very, very powerful tool in helping community to control mosquito breeding sites in the area. Okay, this is take-home message, and I think you guys could try to do some of these yourself. Okay, and hope that the community will appreciate all the things that the GLOBE program and citizen science try to do and help the community. So I'm more than happy, and I'm sure Casey more than happy to answer any question. Thank you. Abraham has raising his hand. Do you want to type in your question, and Casey and I would try our best to answer your question.
Well, my take-home message for this is please update your Globe Observer app to make sure you get all the current imagery and changes that were made. And please, please, please take as many mosquito larvae photographs as possible and join our challenge and help the scientists create an AI that will kind of instantly, we look at our phone, we'd be able to identify the genus of the larvae.
Yeah, if you guys don't really having any question to ask us, I would like to share a little bit more. I think I'm sure that many of you helping coaching your students in your countries and helping them with the IVSS project, right? If you do, it would be fun to associate Mosquito Habitat Mapper app with other globe protocols. For example, you can ask whether water pH that student collecting mosquito larvae in would what kind of water pH that you find your student find most of mosquito larvae in. Let's say some area mosquito might like rainwater, and when you take a look and do a pH measurement, the rainwater usually the pH would be 6.4 or 6.3 or something like that. Okay, and when the water pH turn out to be more like higher, like 8 or something like that, that usually you will find less mosquito larvae. The reason I say this because in cement tank, okay, in cement tank, usually the cement tank is become a little higher pH than like a earthen jar. Okay, for the cement tank, we hardly find anything because not many, even macroinvertebrates, they're not really present. So when it's really the pH really like 8 or 8.5 or 9, so you probably will not find mosquito larvae. So I think is a good you can ask your student to do linear regression plot on water pH, number of mosquito, type of mosquitoes. For example, if your student can identify mosquito like Aedes aegypti, Aedes albopictus, or Culex or Anopheles, this thing, and you plot with the water pH um, and number of mosquito larvae in each species, I think you will earn STEM education badge. I mean, or data, what we call data analysis badge or something like that. Okay, that would be wonderful things. What is a suitable temperature can mosquito live? Uh, from the video, you can see that mosquito, different species prefer different temperature. I mean, different water temperature. But for Aedes aegypti, is I think is between 25 to 35 degrees Celsius is preferable temperature for Aedes species. Casey, would you like to add something?
I think you covered that one.
Another thing that would be interesting is uh, about the air temperature and the amount of rainfall, okay, in your area, and you could relate that with number of mosquito larvae that you find, and also the number of dengue cases in your area. If you can go talk to the health organization group that working on or counting dengue cases or Zika cases or malaria cases, you can ask your student to make a good graph on dengue cases and then monthly rainfall and also number of mosquito larvae that you find in the area. You would be surprised. You would be surprised. I'm going to tell you a story, maybe 1 minute story. In Thailand, in April, it's so dry, no water in the water container, but female, they have to lay egg because their egg is ready, okay? Otherwise, they're going to die. So they lay egg on the edge of water container and the egg will not dry out. It lasts 6 months, maybe a whole year. And when the first rainwater get in, the water rising, okay, until it reach to the top of the water container, the egg will hatch within 2 days. And then you have zillion of mosquitoes flying around, looking and eating you, okay? And that when you get an outbreak because hundred and thousand of egg being accumulated over summer months when there is no water reaching. Okay. So that's why you wonder why all of a sudden there's so many mosquitoes and all of a sudden there's a dengue cases come out. Okay. It would be fun and challenging. Um, Yes, there are also some mosquito species that live in a brackish water. You could do water salinity. Globe protocol has salinity protocol. You can ask your student to do that. You can use the EC electro conductivity meter to measure the salinity or the EC of the water, and that you can plot with the number of mosquito larvae that found and the species of mosquito larvae that found. The brackish water is a great story. If you do it next year, it will be one of the project that would get 4-star and at least 4 badges. Okay. I think we have 1 minute left. I would like to thank all of you to attending this wonderful workshop, and I'm so happy. And I would like Casey to say something before the workshop end.
I also am very thankful that you came. Thank you so much for your interest in mosquitoes and in using the Globe Observer tool, and specifically the mosquito habitat mapper. We definitely want your mosquito larvae observations, your land cover observations, and whatever resources that you're looking for. Check out the Globe Mission Mosquito and Globe Observer web pages. They have complimentary resources and archived webinars. We have things to support you if you're giving presentations to teachers or for students. So we're here to help you. So thank you so much for coming.
Before we end this session, can you turn on your camera? And we would like to take a group photo of the wonderful group of people here. Can we take group photo? How can I view everybody? Is a gallery. Okay, could you please turn on your camera, and then I will see most of you, and I will take a photo. I will post it on my Facebook, but I don't know. Sorry, I will start. I will counting. Okay, everybody smile. 1, 2, 3. You guys look great. I will take a screen caption. Smile. Thank you. That's wonderful. Okay. Thank you, Dave. You guys been wonderful. Thank you, Dave. Thank you, Casey.
Malika. Thank you, Casey. Sawadee krap.
Bye bye.